Welcome to my new video on stressing of pre-stressed concrete girder. To begin the stressing process, we will follow these key steps. First, calculate the stressing data, then perform the stressing of girder at site. In this video, we will focus on how to calculate and prepare the stressing data. Initial the equipment requirements. For stressing operation, we need two sets of equipments: hydraulic jack, hydraulic pump, and the pressure gauge. These three combined assemblies that must be calibrated by a certified institute. From the calibration report, we will extract the calibration formula which is essential for stressing operation. Document required for the stressing calculation. To calculate the stressing data, you need the approved drawing of girder, the coil number and the manufacturer test certificate or MTC, the calibration report of combined assembly. The stressing data must be calculated based on the approved drawing. Stressing calculation. Let's move on the actual stressing calculation. Here a typical girder stressing data template that we have used in our project. Initially, start by entering the known data for the project, the name or location of the structure, girder number, just a mistake it will be 9, date of casting, date of stressing, strength of concrete, length of girder, and the cable number. Now the cable belongs to the coil number. For the coil number, we can find this type of plate attached to every strand coil. In this case, the coil number is B32401291764. The coil number will be required to find out the actual value of modulus of elasticity and the area of strand from the MTC. To find out the theoretical E and A values, need to follow the approved drawing. In the general note, the theoretical design criteria are stated. Pre-stressing cable shall be consist of 19 number 15.24 mm dia strand or 19 T50. Area of each strand is 140 mm square. Modulus of elasticity of strand 197,000 MPa or 197 gigapascal. Now the type of HT cable is 19T15. Test report number 1. The theoretical E value equal to 197,000 MPa equal to 197 gigapascal. Theoretical A value equal to 140 mm square. Now for the actual E and A value, we need the mill test certificate. For coil number P32401291764, the steel area is 140 mm square and the modulus of elasticity is 198 gigapascal. Now from cable profile design drawing page, this is cable number 1, 2 and 3. And the design elongation is for cable 1 is 153, for cable 2 152 and cable 3 151. The design jacking force is 3645 kN for all the three cables. Here for cable number 1, the elongation is 153 mm and the jacking force is 3645 kN. Now the modified elongation equal to theoretical elongation into theoretical area of strand and theoretical modulus of elasticity divided by actual area of strand and actual modulus of elasticity. The value is found 152 mm. The elongation range is plus minus 5%, that is specified in the specification. In the specification, the elongation of the tendon under agreed total forces shall be within 5% of the agreed calculated extension. For our project, the girder has two sides we have mentioned, the Dhaka end and the Sylhet end. Let's look at the calibration data for both hydraulic jack. At Dhaka end, we used jack ID 2410 and the gauge ID 2022113156. The calibration equation is y equal to 7.6383 x minus 2.8203. Here x equal to gauge reading in MPa and y equal to metric ton, and 1 metric ton equal to 9.80665 kilonewton. Now from the drawing, the sequence of stressing of cable 1, 2 and 3 are: for cable number 1, strand need 50% of stressing. Then cable number 2, 100% stressing. Then again cable number 1, it is 100%. And finally the cable number 3, it is 100%. So for cable 1, we need double stroke. Initially stressing 50%, and after completing second cable, we need another 50% stressing. Initially we will start with 50% stress cable 1, and we will need at least 3 data points to plot a graph. As the initial data will be discarded due to zero correction, we will give and record stressing at 10%, 20%, 40% and 50%. Then we will continue with 60%, 80%, 90%, 95%, 100% and 105%. As in the specification, for stressing, we have also 5% tolerance for jacking force, so 95% and 105% are the minimum and maximum range of jacking force. Now we need to calculate the different percentage of jacking force corresponding to 3645 kilonewton. From this, we can calculate the other values. Conversion to MPa. This is the jacking force. To match the pressure gauge which read in MPa, we need to convert the force from kilonewton to ton and then ton to MPa. To convert kilonewton to ton, divide the values by 9.80665. Then we apply the calibration formula to convert ton to MPa and complete the full calculation process. Here 49 MPa equivalent to 3645 kilonewton. As both it have same calculation, then the other side too will be completed in the same way. Now for cable 2. Now we will copy this file for the cable 2 calculation. Here change the value to cable 2. The theoretical elongation is found 152 and the calculation is automatically changed. Now for gauge reading, as this is a single stroke stressing and we will draw a single graph, we will reduce the data level. The percent of reading will be 20, 40, 60, 80, 90, 95, 100 and 105. The cable 3 data will be prepared same as cable 2. The calculation sheet is provided in the video description for your reference at any time. In the next video, we will show how the stressing is done at site. I hope this video helps you a lot. Let me know if you need any further queries. If you like the video, please like, share and comment. Thank you.